Okay, hi everybody. We are now doing video 2 of chapter 6.2, section 6.2, and we are doing the second do now in your packet. I'm going to X this out real quick, and I invite you to copy down these questions right here that are on the board that are not in your packet, and I invite you to pause the video, try to find the volume of each of these figures by yourself, and then resume the video to see if you got the answers correctly. If you can do these, you can do them on the quiz. If you can't do these now, you won't be able to do them on the quiz. All right? So, let's very quickly start working on this. We have, first of all, a rectangular prism. Volume of a rectangular prism, as is the volume of any of these prisms or cylinders, base times height, but our base is a rectangle here, 10 by 5, so it's really length times width, because the length times your width is the area of a rectangle. So length times width times height. Okay? Your volume then is going to be the length, 10 inches, times the width, 5 inches, times the height, 2 inches. And then when you multiply all of these together, you get 10 times 5 is 50, times 2 equals 100 inches. And our units are cubic units because we had, to start with, inches times inches times inches. That's inches to the third power here. Okay? So should be no pi here anywhere because we are not dealing with any kind of shape that has a circle in it. So this is done. We have our answer. The volume is 100 inches cubed. And I am going to join this together, shrink it down a little bit, and we'll go on with number 8. Once again, our volume for number 8 is equal to the area of the base times the height. However, the area of the base here is a circle, so the area is pi times the radius of the circle squared. So the area is equal to pi times the radius, which we have given to us as 11 centimeters squared. 11 times 11 is 121, so we get that the area is equal to 121 pi centimeters squared. Okay? And we are going to leave this in terms of pi until we are done with everything. Otherwise, we're going to have a lot of decimals that we'll have to multiply several times. So we'll just leave this just like this, and we will plug back into our formula because remember, we're in the middle of a formula here. Volume equals base times height, but we just found the base, so volume is equal to your base, 121 pi centimeters squared, okay? And then times your height, which we have given to us as 1.5 centimeters. Okay, so 1.5 times 121 is, well, I'm going to cheat and use a calculator. You can do this with long multiplication, but 121 times 1.5 gives me a volume equal to 181.5. Don't forget pi, because we haven't multiplied pi yet. And then don't forget your units. We had 2 centimeters times centimeters here, and then another centimeter there. So there are actually 3 in total. And besides that, you know we're measuring volume, so it must be centimeters cubed. That is my perfect volume. However, it also asks me to approximate it to the nearest tenth. So what I will do, instead of pi, I will throw in 3.14, and everything else will stay the same except for this equal sign. The equal sign will become approximately because we are now approximating this. 181.5 times 3.14 centimeters cubed stays the same, and I'm once again going to use a calculator to save time, and we get that the volume is approximately equal to 569.91 centimeters cubed. And because I have to approximate this to the nearest tenth, that 1 will go away because it is smaller than 5, so it does not affect the rounding. And we will get 569.9 centimeters cubed. Okay? Now what I am going to do, I'm going to group all of this stuff together. I'm going to group the rest of it together. Oops. I'm going to group the rest of it together. Okay, and I'm going to shrink it all down so that we have room to work on our third question. And I am, just because I like keeping things coordinated, I will turn all the color to blue, because we were working with a blue shape. Okay? Now let's go to yellow. Let me change this real quick. Do yellow. Okay? And we are dealing with a triangular prism now. Okay, and hopefully I'm still in yellow. And notice we have a triangular prism. The formula for finding the area of a prism has not changed. It is still volume equals base times height, except what has changed is our base is now a triangle. So I need to find the area of a triangle, which we have the formula, area equals 1/2 base times height. And I want to take a moment to talk about this base here. The base does not refer, not the base. I want to take a moment to talk about the height. The height does not refer to the height of the pyramid. It refers only to the height of this triangle here. Okay? So they have pointed out that the height of the triangle is 6 meters. So don't get this height here and this height here confused. Try to change my color one more time before we go on. Okay. So it didn't work, but nevertheless, we'll move on. So we have area equals 1/2 times our base, the base of the triangle, which is 9 meters, times the base of the height of the triangle, which is 6 meters. Okay, so we have 1/2 times the base of the triangle times the height of the triangle, and I will just multiply these together. 1/2 times, you know what, I'm going to do it out of order, because 1/2 times 6 gives me a whole number. 1/2 times 6 is 3 meters, and then times my 9 meters. And so my area is going to be 3 times 9, which is 27, and we're doing area, so it's meters squared. Okay? I apologize, folks. We're having some slight board issues, like we do. Okay, so we have 27 meters squared, and we have now found the area of the base here. We still need to plug into our formula here, which is volume is equal to the base, the area of the base, times the height. We know what the area of the base is now. It is 27 meters squared, which we just found. And now we have to times by the height, and this time it is the height of the prism itself. So 27 meters squared times 13 meters. When I multiply, I'm going to use a calculator, but you can do it on paper. 27 times 13, I get 351. And I was multiplying meters squared times meters, so that is meters cubed. And I know my volume is equal to 351 meters cubed, and I am done. Okay? So now we are going to go on with the lesson. And we have two problems to work on in this lesson. One of them is talking about estimating. Estimating is your friend when you are dealing with ugly numbers. Okay? An estimate will give you a close guess of what the answer is going to be without having to do all the ugly multiplication, division with decimals or fractions, etc. So, here's the problem. The Asano Taiko Company of Japan built the world's largest drum in 2000. The drum's diameter was 4.8 meters. That's about 14 feet. Actually, that's closer to 15 feet. So that's a really big drum. Okay? Think about a drum right here where you can have, let's see, you can have me, and you can have Mr. Hale, and then you've got another short person that all fit inside of the drum. So that's a really big drum. That's the diameter of this drum, and then its height was 4.5 meters. That's about 15 feet again. So the same thing goes with people stacked down. Okay, you've got one person there, you've got another person there, and the poor person on the bottom has to support the weight of two other people on their shoulders, and that's got to be uncomfortable. But that's the size of this drum here. Okay? I wonder how loud that thing would be if you could actually... And I'm not sure how you bang on the thing, because, you know, you'd need a stick about the size of, you know, a classroom. So, that's interesting. Anyway, it says to estimate the volume of the drum. This is still, even though it's really big, a cylinder. So our volume of cylinder is, again, the area of the base times the height, and the area of the base, area of a circle, is pi r squared. Now, the radius here is what we need to worry about, but we're not given the radius. We're given that the height, or I'm sorry, that the diameter is 4.8 meters. Now half of that is 2.4 meters, but I'm just going to say 2.5, okay? Because working with halves is a little bit easier. I'm going to say that's about 2.5 meters. And when I multiply, when I plug in for the radius, I get area of the circle is equal to pi times 2.5 squared. Okay? 2.5 times 2.5, 25 times 25, gives me 2.5 squared is 6.25. And here's where the beauty of estimation comes in. That's now a 6. And it's approximately equal to 6 pi meters squared. Okay? Now I'm going to talk about the height. The height, or even before I get to the height, because I am approximating, I am going to say, hey, you know what? This pi, let's plug in for that, but let's not use 3.14 right now. Because I want to approximate, and I can't stress this enough, it says to estimate the volume of the drum, so that is why we're allowed to do this. I can say this is about 6 times 3 meters squared, which is about 18 meters squared. Now I'm going to very quickly do the exact area right now. So that is pi. Let me just grab it real quick. Pi times the radius, which is 2.4 squared. And so my exact area of this base is 18.1 if we round it. Look at that. This is why we can estimate sometimes, because 18.1 and 18 aren't really that different, right? Okay, so we haven't really gotten too crazy by leaving off some of our exactness. Okay? So, now that I have the area of this circle, I will go ahead and find my volume, because my volume is equal to the area of the base times the height, and I know the area of the base. I just said it was about 18 meters squared, and my height is 4.95. What do you think I'm going to round that to? Sure, it's going to be 5 meters. So if I do 18 times 5, the volume is approximately equal to 18 times 5. 18 times 5 is going to give us about 90, and we're talking about meters cubed. So that's what we get. And I will tell you right now, the exact answer was 89.6 meters cubed. So we were very, very close, and we saved ourselves some of the ugly numbers. Okay? If you wanted to estimate a little bit sketchier, you could have, instead of calling that 2.5, you could have called that 2, and then we're even easier. Okay? So that's estimating, and that's what some of the beauty of that is. And I'm going to let you have this one for you to try. You are going to estimate the volume of the toy box that is 5.1 centimeters by 3.2 centimeters by 4.2 centimeters. And I'll give you a hint. Immediately, before you start anything, change those numbers to something that's prettier to work with. You might have to pause the video and write down that question because it's not on your slide, and we are going on in the video. It says to find the volume of this barn that is shown. And the question I want you to ask yourselves is, what shape or shapes is the barn made of? Okay? Because it is neither a cylinder nor a prism that we have talked about so far, but we can split it up into two parts. We can split it up into this rectangular piece, right? And then separately, we have this triangular prism on top, okay? And we can find the volume of this shape here. Volume equals something. And we can find the volume of this shape here. Volume equals something. And then to find the volume of the barn would just be volume of the triangular prism plus the volume of my rectangular prism. Okay? So all I would have to do is add up those two volumes that I found, and I would get the volume of my barn. So this is very straightforward at that point. We first find the volume of our triangular piece. Okay? And that is equal to, again, the base times the height. But my base is a triangle, so the area of that is equal to 1/2 times base times height. And I need to be very careful to pick my correct base. The base of my triangle is this right here. Okay? That's my base, and that is 40 feet. So I'm going to do 40 feet for my base. I'm going to plug that in for base. Okay? And then my height of my triangle is this height right here, which they tell us is 10 feet. So I'm going to plug in for height 10 feet. And the 1/2 stays the same. So my area of my triangle is equal to 1/2 times 40 times 10. Well, half of 40 is 20 feet times 10. 20 times 10 is going to equal, area equals 200, and I have 200 feet squared. And again, because we are talking about area right now and not volume, we are going to talk about square units. Okay? So that is all for the base. Okay? I'm trying to move this over here. So this can go over here so that I can then, I apologize, undo that, and undo the shaking it apart, and I have my area here is equal to all of this. And now I will plug back into my formula because I still need to find the volume of this triangular prism. The volume is equal to the area of the base, which is 200 feet squared, which we've already found right over here, times my height, which is the height of my triangular prism. And the height is not the height of the triangle, it is the height, let me get a color that we can actually see in contrast here. It is the height of this right here. It's the height of the whole prism, not the height of the triangle. That height is right here, 50 feet. Okay? So I'm going to multiply this by 50 feet, and I have 200 times 50, which is going to be 10,000. V equals 10,000 feet squared. Sorry, I just made that mistake. Feet cubed, because we're talking about volume now. We have found the volume of the triangular prism. And now what we need to do, you might want to pause the video, but I am going to shrink all this. Okay, now I can shrink it all up so that we can then do the volume of our rectangular prism. Now the volume of the rectangular prism, I was actually using green for that, so I'll keep it as green. The volume of the rectangular prism is, as always, base times height, and the base here is this thing right here. Okay, so that is 40 feet by, how high is this? That is 15 feet high. Okay, so that's my base, is 15 feet times 40 feet. Okay? And then I'm going to multiply those together. I get 15 times 40 is 600 square feet. And now what do I have to do? That's my area. This was my area of my rectangle. Area of my rectangle. That's that. So now I still need to multiply by the height here. So I take 600 square feet times my height. And what is my height of my prism? My height of my prism is the long side here, this 50-foot side. So I get 600 feet times 50 feet. 600 times 50 is 30,000 feet. And notice I'm doing volume, so I have feet cubed. Now, am I done? Well, not quite, because I still have to find the volume of the barn. Volume of the barn is equal to my volume of my triangular prism, which what we found to be 10,000 feet cubed, plus my volume of my rectangular prism, which I found to be 30,000 feet cubed. Okay? And so my volume of my barn is equal to 10,000 plus 30,000, and they are the same unit, so I can just add them up. I get 40,000 feet cubed. And that is how you do it. Quick recap. You can, of course, rewind the video and watch it again, but a quick recap. To find the volume of this shape right here, I find that I have a rectangular prism here in the bottom of it. I can find the volume of that. We've been doing it for a couple of days now. And then I find that I also, on top of that, have a triangular prism. And so I find the volume separately, I add them together, and that is how I find my volume. Okay? So now you have a question that you can work on your own. You will have to pause the video and watch it. Okay? You will be able to find this volume pretty simply. It's not that much more difficult. Okay? We've got a rectangular prism as your base here. We've got a triangular prism as your roof, and you can find the volume of a treehouse. For example, you might want to know how many peanuts could you fit in a treehouse if you filled it from floor to ceiling. The volume of it would help you to solve that problem. Okay? I'm going to give you a preview of the exit ticket you might be asked to do in class. Okay? It is asking you to find the volume of a shed below. You might have something like that as a question. Okay? I stress strongly that at this point you go back and rewatch any parts that you did not understand, or you make sure that you can answer all of the questions that are given to you, because there will be a mini quiz on one or two of these questions when you come to class. Okay? Enjoy the rest of your weekend, everybody, and I will see you on Monday. Okay.